Welcome students, welcome to this session. So let's see the hydraulic energy. So hydraulic energy is what is produced by the water which is stored in reservoirs and lakes at a high altitude so that it has gravitational potential energy. If at a given moment it falls to a lower level, this energy is transformed into kinetic energy and afterwards into electrical energy in the hydroelectric plant. This is the layout of hydroelectric power plant. So this is the water storage in the higher altitude. From the higher altitude, water is flows through the penstock and it hits the turbine. It impulses the turbine and it impulses to rotate the turbine blades so that the turbine rotates and it turns coupled with the generator. That generator rotates, it produces electricity and this electricity is supplied to the grid and this water is discharged. Hydroelectric hydropower plants capture the energy of falling water to generate electricity. A turbine converts the kinetic energy of falling water into mechanical energy. Then a generator converts the mechanical energy from the turbine into electric energy. Hydro plants ranges in sizes from micro hydros that powers only a few homes to giant dams that provide electricity for. Let's see the parts of the hydroelectric power plant. The most conventional hydroelectric power plant includes four major components. First is the dam. It raises the water level of the river to create falling water. Also controls the flow of water. The reservoir that is formed is in effect stored energy. Then comes the turbine. The force of falling water pushing against the turbine's blades causes the turbine to spin. A water turbine is much like a windmill, except the energy is provided by falling water instead of wind. The turbine converts the kinetic energy of falling water into mechanical. Then comes the generator. Connected, the generator connected to the turbine by shafts and possibly gears. So when the turbine spins, it causes the generator to spin also. It converts the mechanical energy from the turbine into electrical energy. The generators in hydropower plants works just like the generators in other types of power plants. Then comes the transmission lines. Conducts electricity from hydropower plants to homes and business. Now let's see the video of how hydroelectric power plant works.
170,000 cubic meters of water flow past here every minute at almost 60 kilometers per hour. That's enough water to fill about 100,000 Olympic swimming pools every day. Standing here, you can actually feel the power of the water. Harnessing that power is what hydroelectric stations have been designed to do for over 100 years in Ontario. In essence, they are factories that convert the energy of falling water into the flow of electrons, or what is commonly called electricity, the electricity that powers the province. Most hydroelectric stations use either water diverted around the natural drop of a river, such as a waterfall or rapids, or a dam is built across a river to raise the water level and provide the drop needed to create a driving force. Water at the higher level is collected in the forebay. It flows through the plant intake into a pipe called a penstock, which carries it down to a turbine water wheel at the lower water level. The water pressure increases as it flows down the penstock. It is this pressure and flow that drives the turbine that is connected to the generator. Inside the generator is the rotor that is spun by the turbine. Large electromagnets are attached to the rotor located within coils of copper wire called the stator. As the generator rotor spins the magnets, a flow of electrons is created in the coils of the stator. This produces electricity that can be stepped up in voltage through the station transformers and sent across transmission lines. The falling water, having served its purpose, exits the generating station to the tail race, where it rejoins the main stream of the river to continue the cycle of creating clean, renewable energy for Ontario.
Now let's see the advantages of hydroelectric power plant. Once a dam is constructed, electricity can be produced at a constant rate. If electricity is not needed, the sluice gates can be shut, stopping electricity generation. The water can be saved for use another time when electricity demand is high. Dams are designed to last many decades and so can contribute to the generation of electricity for many years or decades. The lake that forms behind the dam can be used for water sports and leisure or pleasure activities. Often large dams become tourist attractions in their own right. The lake's water can be used for irrigation purposes. The buildup of water in the lakes means that energy can be stored until needed when the water is released to produce electricity. When in use, electricity produced by dam systems do not produce greenhouse gases. They do not pollute the atmosphere. Now let's see the disadvantages of hydroelectric power plant. Dams are extremely expensive to build and must be built to a very high standard. The high cost of dam construction means that they must operate for many decades to become profitable. The flooding of large areas of land means that the natural environment is destroyed. If you are constructing a large dam, it means flooding the large area of land so that the forest under this area must be destroyed. People living in villages and towns that are in the valley to be flooded must move out. This means that they lose their farms and businesses. In some countries, people are forcibly removed so that hydropower schemes can go ahead. Now let's see the nuclear power plant. This nuclear power plant is which utilizes the nuclear energy as a fuel. Nuclear energy is energy in the nucleus of an atom. Atoms are tiny particles that make up every object in the universe. This is how the sun produces energy. In nuclear fission, atoms are split apart to form smaller atoms, releasing energy. Nuclear power plants use nuclear fission to produce electricity. This is the layout of how this nuclear fission action happens. When one neutron which hits the uranium atom, it gets fission into so many small lighter element and one neutron. And again, this one neutron will hit the another uranium element. It gets splitted into so many element and neutrons. So this chain reaction continues. So by producing large, enormous amount of heat, enormous amount of thermal energy is released during this fission reaction. So this is how the nuclear power plant layout looks like. So this is the concrete shield. Inside this is the fuel moderator, fuel and moderator. And this fuel and moderator is kept inside the thermal shield. Okay. When this fuel is when the fission reaction is happening inside, it produces enormous amount of thermal energy. It releases them heat so that this when water is circulating inside this circuit, it absorbs the heat and becomes steam, and it comes to this heat exchanger, and it releases the heat to the secondary circuit, and again it comes through the cycle through the circulating pump. And in the secondary circuit, the same water which absorbs this heat and becomes steam, and it runs a turbine, and in turn which runs a generator, and from the turbine the steam is enter into the condenser. It condenses, then it using the feed pump, again it's pumped into the heat exchanger. Why we are providing primary and secondary heat exchanger is, this primary heat exchanger, the water comes out from this reactor, it's having a radioactive elements. some of the radioactive elements which is harmful to the atmosphere and in turn harmful to the elements also. For that reason, we are using the secondary circuit. A nuclear power plant is actually like a water heat exchanger. Water at high pressure is pumped through the reactor core to get the heat energy from the chain reaction. Water is kept at very high pressure to prevent boiling. This high pressure radioactive water is then circulated through the steam generator in the closed cycle to transfer its heat to the boiler feed water in another closed cycle loop to convert feed water into steam. Using these two loops helps to keep away contaminated water from the other equipment of the plant like turbine and condenser. Steam is then supplied to the conventional steam turbine generator to produce electricity. From the turbine, the steam is condensed to liquid phase in a condenser and returned as feed water to the steam generator. Now let's see the video of how this nuclear power plant working principle.
Friends, let's take a moment to understand the working of a nuclear reactor. Nuclear reactors are the modern-day devices which are used extensively for generation of power. Earlier, we used coal and other non-renewable sources for the purpose of power generation. But since we are running out of them at a very rapid pace, we need to look at sustainable and possible and eco-friendly way of moving forward. The nuclear reactor consists of three core components: fuel elements, moderator, control rods. Fuel elements consist of cylindrical rods put into bundles. A uranium oxide ceramic is formed into pellets and inserted into zircaloy tubes that are bundled together and contain fissionable nuclei of uranium-235 or uranium-238. The number of rods varies greatly according to the size of the reactor. The fuel elements are placed inside the reactor core. The fuel elements are immersed in water which act as a moderator. Moderator is essential in slowing down the energy in neutrons in nuclear reactors which are produced during the fission process by the fuel elements. Normal or heavy water is generally used as a moderator. Thermal neutrons produce fission reaction with uranium-235, and during this process, new neutrons are given out which have the energy of about 1 MeV or 1 mega electron volts. These new neutrons typically escape from other fission process as they are accompanied by huge energy with them. Here, moderators come into play. Moderators have the capacity to slow down these high energy neutrons. Water molecules present in the moderator are also instrumental in slowing down further the speed of high energy neutrons. The new reaction then takes place with the slowed down neutrons by striking them with fuel elements. A liquid or gas circulating through the core so as to transfer the heat from it. In light water reactors, moderator also functions as a coolant. Usually, a robust steel vessel containing the reactor core and moderator or coolant, but it may be a series of tubes holding the fuel and conveying the coolant through the moderator. Another very important part of the nuclear reactor is the control rods. We would like to have the steady flow of energy from the reaction, isn't it? For that purpose, every single fission reaction leaves spare neutrons which in turn are utilized for more subsequent reactions. The control over the spare neutrons available at any given time, the rate of nuclear chain reaction can be controlled. This control on fission reaction can be maintained using control rods. Control rods work by absorbing the excess or spare neutrons in the moderator to prevent any further fission reactions. These rods are usually made up of boron or cadmium. To increase the rate of reaction, the control rods can be removed by the moderator. A steady output of energy must be maintained by inserting or removing the control rods in the reactor. Apart from the above, three other important core components of a nuclear reactor are as follows: pressure vessel or pressure tubes, pressurizer, steam generator. Now that we have understood the various elements of the nuclear reactor, let us see the entire operations in the nuclear reactor. Nuclear reactor consists of a reactor core, pump, and the heat exchanger. Due to the enormous amount of heat produced and then released during the fission process, surrounding water gets heated up and changes into steam. This steam turns the turbine, thereby starting the generator which produces electricity, lighting up our world.
Now let's see the advantages of nuclear power plant. There are a lot of advantages of nuclear power plant as compared to other power plants. Since the requirement of fuel is very small, so the cost of fuel transportation, storage, etc. is small. Nuclear power plant needs less space as compared to any other power plant station of the same size. This type of power plant is very economical to produce large electric power. Nuclear power plant can be located near load center because bulk amount of fuel like water, coal is not required. Nuclear power plant is most economical to generate large capacities of power like 100 mega volt amperes or more. Using a small amount of fuel, this plant produces large electric energy. This plant is very reliable in operation. Nuclear power plant is very neat and clean as compared to a steam power plant. The operating cost is low at this power plant, but it is not affected for higher load demand. Let's see the disadvantages of nuclear power plant. Though nuclear power plants has above advantages, but there are some disadvantages of nuclear power plant too. Initial installation cost is very high as compared to the other power station. Nuclear fuel is very much expensive and it is difficult to recover. The capital cost is higher in respect of other power station. Good technical knowledge is required to operate such type plant. So salary bill and other maintenance cost will be higher to operate such a plant. There is a chance to spread of radioactive pollution from this type of plant. Nuclear reactor does not respond efficiently with the fluctuating load demand. So it is not suited for varying the load. Cooling water requirement is twice than a coal-based. Now let us see the another type of fuel source of energy is the fuel cell. A fuel cell is an electrochemical cell that converts the chemical energy of a fuel, often hydrogen, and an oxidizing agent, often oxygen, into electricity through a. Fuel cells are different from most batteries in requiring a continuous source of fuel and oxygen to sustain the chemical reaction. Whereas in a battery, the chemical energy usually comes from metals and their ions or oxides that are commonly already present in the battery except in flow batteries. Fuel cells can produce electricity continuously for as long as fuel and oxygen are supplied. Now let's see how this fuel cell is working through this video. We are using hydrogen separately and oxygen separately to produce electricity. This is the fuel cell. and at the same time oxygen is entered into this passage. This gets sucked into the cathode. This electrolyte is used for storing this hydrogen electrons to move into the anode, so that when hydrogen electrons get combined with the oxygen atom to produce water, and the water molecules move from this section. And when the hydrogen and the electrons and when the hydrogen gets combined with this anode, electrons is producing. This electron separated electrons will go through this passage and it produce electricity. Now let's see the types of fuel cells. The photon exchange membrane fuel cells, that is represented as PEMFCs, phosphoric acid fuel cells, solid acid fuel cell, alkaline fuel cell, high temperature fuel cell, electric storage fuel cell. These are the fuel cells. These are apart from the hydrogen fuel. What are the advantages of fuel cell? It is readily available. It does not produce harmful emissions. It is environmentally friendly. It can be used as fuel in rockets, because in rockets we can't store the fuel as like stored in vehicles. Wherever we necessary, we can store the chemicals separately. If the fuel is needed, means at that time we can combine the chemicals to produce this type of fuels. So it is fuel efficient. It is renewable. And disadvantages of fuel cell: it is expensive, it is difficult to store, it is not easy to replace exiting infrastructure, and it is highly inflammable since we are using completely the chemicals, and it dependent on fossil fuels, because we need some chemicals. That chemicals we recover from the fossil fuels only. Thank you, students. Thank you for watching this session. We'll see you in the next class.